Okay, so welcome to the second part of lecture 3. We're still looking at grouped data. Still looking at grouped data. Okay, so in this example, we're given the following table. We have the class there. So the first one, we have 200, but less than. Okay, so in this, let me just do this. So we have 200, but less than 210. And the frequency there, we have a 2. Then we have 210. I have a 210. But less than 220. The frequency is 5. 220. But less than 230. The frequency there is 6. 230. But less than 240. And there the frequency is 8. 240. But less than 250. Okay, these classes I lot. 4. 250, but less than 260. The frequency there is 3. 260, but less than 270. The frequency is 1. Okay, so these are the classes that we have. 1, 2, 3, 4, 5, 6, 7. Okay, so we have the classes. Now we need to find the mean, the mode, the median, the variance, standard deviation, and coefficients of variation. Okay, so those are the parameters that we need to find. Let's start with the mean. Okay, so, and actually we are given that this is the time that it takes for 29 people to exercise. Okay, so this is the time that is taken to exercise. So the mean time is just given by the summation. Remember, this is grouped data, so we need to use the midpoint. So get the frequency, multiply by the midpoint, and then we get the sum of the frequencies. In the previous, we said this is our n. So you just have to know that this is either, it's n, it can also be written as, okay, I can say sum of the frequencies is also the same as n. Okay, so this is our This is our formula. So that means we have to find the midpoint for the frequencies. So I'll just do this. I'll shorten this 100 but less than 210. I'll just write 100 to 210. Okay, because of space on the gadget I'm using. Okay, so have again we have the class. So this is the part where I said I'm going to use, I'll just shorten 200 to 210, 210 to 220, 220 to 230, then we have 230 to 240, 240 to 250, 250 to 260, 260 to 270. Okay, so we'll put the frequencies there. The frequencies we have 2, 5, 6, 8, 4, 3, 1. Now according to the formula, we need the midpoints, which are the xi's. Okay, so the midpoint, you just get the lower limit and the upper limit, you add and divide by 2. So here the first one we have 200 plus 210 divided by 2. It gives you a 205. 210 plus 220 divided by 2, it gives you a 215. So you do that, you get these values. Okay, so we can as well just find the totals there. So for the so this is the one. So for the frequencies, the total there is 29. Okay. Now according to the formula, we have to multiply fi times by xi. So you multiply 2 by 205 here. So this is our fi multiplied by xi. So this is our 410 5 times 215, that gives you 1075. Here we have 1350. There we have 1880. There we have 980. 765 and 265. Okay, remember we want the sum. So the sum there, the sum is just 6725. Okay, so we go back to our formula. The mean time just equal to the summation of fi xi over summation of fi. There the sum is 6725 divided by 29. Then this gives you 231.8965. You just approximate it to 2 decimal places. 231.90. So that is your mean. Okay. Okay, so that's how we get our mean. Let's go to the mode. The mode time. Remember, this is just the time that was taken, that it takes for 29 people to exercise. Okay, so for the mode, remember the mode is just the value with the highest frequency. Okay, so that is the starting point. That is your starting point. So we first look, in this case for grouped data, we look for the class with the highest frequency, and that becomes our model class. Okay. Okay, so let's look at the class with the highest frequency, and this class is the class from 230 to 240. Okay, so that is our model class. So from there, so our model class is the one from 230 to 240, and then we need to find the formula now. Let's get our formula. Mod is just equals to the lower limit plus, open brackets, the frequency of the model class minus the frequency before over frequency of the model class minus frequency before. Okay, so we have this plus frequency of the model class minus. Okay, so let's do this. So start from there. Mod is equals to lower limit plus, open brackets, frequency of the model class minus the frequency of the class before over frequency of the model class minus the frequency of the class before plus frequency of the model class minus frequency after of the class after, then everything we're going to multiply by the class we did. Okay, so what is our lower limit? Our lower limit therefore is 230. That is the lower limit of the class of the model class. The frequency of the model class is 8. The frequency before the model class is 6. Frequency after the model class is 4. The class we did. Just get any two lower limits or any upper limits and find the differences. You can say 210 minus 200. This gives you a 10. So that is our class limit, our class we did. So we can then just put all our terms in the formula, and we find the mode is just 230 plus, open brackets, 8 minus 6 over 8 minus 6 plus 8 minus 4 multiplied by 10. And this gives us 230 plus 2 over 6 times 10 gives us 230 plus 3.333, and this is 233.333. Okay, so, and that is our mode, the model time. Okay, so we have found our mode, and now we are going to find the median. So the median time, remember the definition of the median? The median just the value that separates the data set into halves. The formula is given by L that, and then cumulative frequency before the median class over the frequency of the median class multiplied by the class we did. So we have to look at the position of where the median will fall. So we're looking for the class. So we get our n, and we're going to divide it by 2. So which is 29 divided by 2. Okay. So when we do that, and this is just an emphasis that we should have our calculators. Okay. So if we do that, we're going to find 14.5. This is approximately 15. Okay. So now we go in on our table. Then you can see that the classes have been arranged in such a way that we have the smallest to the biggest. Okay, so that means that the smallest, the classes, they begin from 200 to 210, then the last one is 260 to 270. So this just shows you that there is some order. The classes have been ordered. Okay, so now we have to look for the cumulative frequency. The cumulative frequency will help us know in which class interval the 15th value lies, and that is the value that divides the data set in halves. So the cumulative frequency for the first class is 2, then we have 7, then we have 13, we have 21, 25, 28, 29. Okay, now we are looking for the class in which we are going to find the 15th value. So the 15th value, you can see here there are only 13. The 15th value will lie in this class. That is 230 to 240, and this class we'll take it as the median class, the class that contains the median. So that class is 230 to 240. So according to the formula, we have to look for the cumulative frequency before this class, which is just 13. Okay, and the frequency of the median class is 8. Okay, so therefore we're going to put in our formula. The median time is just equal to our lower, maybe we can write it down here. Okay, let me just put the formula. N over 2 minus the cumulative frequency before over frequency of the median class. Remember this bracket extend up to there times the class we did. Okay, so we replace maybe before that, let's just put our terms. L is 230, n over 2 is equals to 14.5. So use the value that you originally found and not the approximated value. 14.5. Then the cumulative frequency before the median class is 13. The frequency of the median class is 8. And the class we did is 10. Okay. So now we can have our our median. L is 230 plus 14.5 minus the frequency before, which is 13 over 8 multiplied by 10. Okay, so this gives us 230 plus 1.875, and it gives us 231.875, which can be approximated as 231.88. Okay, so that's how we get the median. Okay, so please always identify the median. It's not always true that the median class is also the same as the model class. So you have to know how to identify the median class. Okay, and now we move to the variance. Now, I gave you two formulas from the previous lecture of the variance. So in example 1, I used one formula, and in this one, I'm going to use the other formula. So you can just choose the one that is that works out for you. Okay, so with this one, we're going to say variance is just equal to summation of x. Okay, let's start with fi. Summation of fi xi, and here put square, minus summation of fi xi squared over n, everything divided by n minus 1. The goodness with using this formula is that you say the fi times xi, usually you would have it because this is the term that you use in finding the mean. Okay, so since we have it on the table, okay, so this is the summation of fi xi. We just square it. Okay, so it means that we have this term already. So now we just supposed to look for the fi times xi squared. Okay, so we go back to our table. We have our classes, and we have our fi. Then we have to look for the xi. Then we have to square. Remember, this is fi times xi squared, so we have to square the midpoints. After we square, that's when we can look for this term. And we're looking for the sum when we sum everything. Okay, so now I'm just I know you have this from now, so what I'll do, I'll just put in the frequencies 2, 3, 2, 5, 6, 8, 4, 3, 1. And the midpoints, we have 205, 215, 225, 235, 245, 255, and 265. Okay, so now we need to square. We need to square these values. When we square the midpoints, the first one is 205 squared. We're going to have a 4 2025. Then 215 squared, we're going to have 46225. Then we have 50625, 55225, 60025, 65025, 70225. Okay, so those are the values when we square the midpoints. We're looking for the next column, we're looking for the frequency times the midpoint squared. So for the first one, we have 2 times 42,025. So this gives us 8405. Then we have 2, 3, 11, 25, 303750, 441800. Then we have 240100, 195075, and 70225. Okay, now you get the sum, which is just the total. When you get the total, you're going to find 1566125. So we're going to find 1566125. Okay, so this is the value that we are looking for. Remember, our variance is just the sum of the fi xi squared minus sum of fi xi, but we square everything, over n minus 1. So we have this term now, which is 1566125 minus, remember this was 6, okay, so this is 6725 squared over the n is just sum of the frequencies, so this is 29, and everything you divide by 29 minus 1. This will give you just right here 1566125 minus 45225 625 over 29 and 28 there. Okay. So we compute that. We compute that, and we're going to find, okay, 6620.69 over 28, and it gives you 236.453. And this is approximately 236.45. On there we have our variance. Okay. Now that we have the variance, we can easily find the standard deviation and the coefficient of variation. So the standard deviation, just known as S. So S is just the square root of the variance. So this gives the square root of 236.453. So when you're computing, use the original value and not the approximated value. So this will give us 15.377, which is just approximately 15.38. Okay, and finally we compute the coefficient of variation. So our CV is just equal to S over X bar times 100%, and then this is 15.377 over, our mean was 231.90. I think this is approximated. $8,965. $8,965 times 100%, and that gives us, let's compute that. I'll have 231. So this gives us 0.066309.8 times 100. 63098%, and it's approximately 6.63%. Okay, and there we have our coefficient of variation. Okay, so this is where we end. I'm sure we have done a lot of examples just to illustrate on how we can find the measures of central tendency and dispersion for grouped data. Okay, so this is where we end with the second part of lecture 3. We'll also have the third part of lecture 3. Okay, thank you very much.